Hello, my name is Ardi and we are going to solve this problem, and the question is asking us about how much is the value of V0 using superposition. So let's break superposition step by step. The first thing that we need to do is to split this into some circuits. So we will need to split to some other circuits. And then what else that we need to do? In each circuit, in each circuit, all but one sources are turned off. Okay. And what does that mean? Here we have two sources, this 12-volt voltage source and this 2 milliampere current source. So we take turn here. We turn off this 12-volt voltage source and then we turn off this current source. So we will have two separate circuit here. And how to turn off the sources? So if we have voltage source, turning off means that it's replaced by short circuit, right? And then the second one, if we have a current source, we replace it by open circuit. So here we will have two separate circuit. The first one, we replace this 12-volt voltage source by short circuit. And then the second one, we replace this current source with open circuit. So let's see how the circuit looks like. How the circuits look like. Let's see the first circuit. Let's turn off the 12-volt voltage source. Okay, we replace this one here, 12-volt, by short circuit. So it will looks like this. And we still have that 3 kilo ohm resistor, right? 3 kilo ohm resistor. And then we still have that current source. So it will looks like this, and the value will be 2 milliampere. Good. And then what else that we get? I got that 4 kilo ohm here. And then we also still have that 2 kilo ohm resistor. So we have this 2 kilo ohm resistor. 2 kilo ohm. And we are looking for V0 here. But here we have different V0 than the circuit. So we name this here as V0 prime. Okay. And I think that's all for this voltage source. Now let's take turn. We turn off this 2 milliampere current source. Okay, let's do that. Let's turn off 3 ampere current source. So we replace this by open circuit. And let's draw the circuit here. So we will have that 12-volt voltage source. And then we have that 3 kilo ohm resistor. And then what else that we got? We open this one, right? We replace this 2 milliampere current source with open circuit, so we don't have anything here. And then here we will have that 4 kilo ohm. So we have 4 kilo ohm. And then we still have that 2 kilo ohm resistor. Okay, we have 2 kilo ohm. And here is our V0. But this V0 is not the same as the original circuit, and it's also not the same as this one. So we name it V0 double prime. Good. And now we have the two circuit splitted. So we will need to do analyze each circuit. Analyze and solve all circuits, all the circuits. And that is the second step. Okay, let's do exactly that. But I need some space, so let's clean up first. Okay, now we have these two separate circuits. We need to analyze them independently. Okay, now let's do this. I think I will use this node here. Let's name this node as VA, and I assume the direction of the current, it goes there, there, and then there, right? So I can do KCL at VA. KCL at VA. What does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. What is the current that goes in? Nothing. We have nothing that goes in, so I will have 0 on the left-hand side. And then on the right-hand side, the current that goes out, I will have this one, VA, where the current comes from, and then it goes here. Maybe let's assume this one here as our ground. So the voltage here will be 0, and that will be VA minus 0 divided by the resistance between them, which is 3. Good. And then here we have exactly 2 milliampere, so I'll have plus 2. And then what else? We have this one here, which is sec VA. So I'll have plus VA minus 0 divided by 4 plus 2, right? Because this is in series, so I will have 6 here. Multiply both sides by 6. Okay, so we will have 0 here. And then this one will be 2 VA. And then we will have plus 12. And then we will have plus 6 and 6 will cancel each other, so we'll have VA. Good. Now let's move things around. So we will have minus 3 VA is equal to 12, and that 4, we will have VA here is equal to minus 4. But that is VA. We need to find out V0 prime. We just use voltage divider, right? Voltage divider. So what is V0 prime? V0 prime is just 2 divided by 4 plus 2, and then multiplied by VA. Right, VA. So let's plug that in. So I will have 2 divided by 6, but then VA is minus 4. 2 multiplied by minus 4 is minus 8. So I will have V0 prime is equal to minus 8 over 6. Or divide both sides by 2 here. So we'll have minus 4 over 3 volt. Okay, and this is one of the most important value, V0 prime. Let's do another most important value, which is V0 double prime, which we can get from this circuit, right? And I think this is a simple circuit rather than this one. This is simpler. We can just use voltage divider, right? We can just use voltage divider. And what can we get from here? We can get that 2 kilo ohm. So we'll have V0 double prime is equal to 2 kilo ohm here divided by 3, and then plus 4, and then plus 2. And that will be multiplied by this voltage source, which is 12. Okay, 2 multiplied by 12, that will be 24. And then divided by 3 plus 4 plus 2, that will be 9. Okay, and then divide numerator and denominator by 3, I will have 8 over 3. And we have the value of V0 double prime, which is 8 over 3 volt. Okay, and this is our V0 prime. And then we are ready to do the final step of the equation. So we can just add them up. Add up the result. In our case, we need to find out V0 here, but then that is the addition between V0 prime and then V0 double prime. So we will have V0 is equal to V0 prime and plus V0 double prime, like this. Okay, we know that V0 prime is this value and V0 double prime is this value. So we can plug the final result. Final results. Remember that V0 is equal to V0 prime and then plus V0 double prime. Okay, V0 prime, we will have minus 4 divided by 3, and then plus V0 double prime is 8 divided by 3. Okay, we will have V0 is equal to minus 4 plus 8, that will be 4. And then we have the same denominator, so we'll have 4 divided by 3 volt. Or if we write it in decimal, we will have V0 is equal to 1.33. And the unit will be in volt. And this is the final answer for this problem. Okay, hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.